but thank you. Oh, this is our last lecture together. We're not going to meet at all next week. It's going to be presentations. So anyway, we'll see you guys sometime next week for your final presentations. Okay, so in our last day of content, we'll just kind of do a little bit more SQL stuff, and we'll take a look at some of the neat things that you can build up. So on Monday, we covered just kind of basic ideas of SQL, querying things, selecting columns, filtering out the rows by using the where statement, and then we looked at the very basic join statement, which is the inner join. Okay, there are other join statements as well: the left join, the right join, and the outer join. And those are basically the inner join is an intersection. So if you got table A and table B, inner join will only return rows where the you have elements that exist in both tables A and B. The left join will include everything that's in table A and only and the matching rows in table B. The right join will include all the rows from table B and only the matching rows from table A. And then the outer join will be the union and includes all the rows in table A and table B. But well, anyway, we won't worry too much about that. We're just going to load up our data using the SQLite database, using SQL Alchemy and Create Engine, and then we'll just kind of verify that we indeed have a connection to the database, and we can just take a look at some of these tables and think about the kinds of tables that we might want to build. Okay, so again, this is kind of an idea of like a music store where they're selling music tracks. And they also have customer information and the order information and things like that. Okay, so if I just take a quick look at some of these tables, I can just say select all the columns from the album table. All right, and this is what we have. Basically, the only information that's unique to this thing is the title, and we have there's an album table and there's an artist table, okay, with artist ID. So we can take a look at what we have for artist. And the artist table is just the names. It's just a matching so that the name from here is produced here. And the reason why we want this is to avoid duplicate information. We don't want to actually list out that 1 is AC/DC and 2 is except, because I can have except here and except here maybe capitalized differently or something like that. And then we would have conflicting information regarding who the artist is. And so as far as except being the name of the artist, it only shows up once, okay? And it just gets matched every time there's a 2. Okay, here is an example of an invoice, okay? So the invoice will has an invoice ID, a customer ID, the date of the invoice, and then kind of the billing information and the total for that order, that invoice order. Okay. If we wanted a breakdown, that information is stored on invoice line. Okay. And again, we don't. We want to separate out these tables. Okay. So there's the total is $1.98 here, and we can see that invoice ID 1 has 2 entries in the invoice line table. Okay, so it's got 2 entries, and so in the printout, we're going to have all of this kind of customer information. Okay, their billing address. Okay, and then we're going to get it was 99 cents. They ordered 2 songs, each of them being 99 cents. Okay, the information regarding what they ordered is linked to track ID. Okay, so track ID is going to have information about the songs that they ordered. Okay, and so we can see track ID 2, the person ordered Balls to the Wall, which comes from album ID 2, and media type and genre ID, and has all of this other information. This is how big that file is and stuff like that. And it costs 99 cents. Okay. And then over here with track ID 4, they ordered Restless and Wild, and it has this information. Okay. And you know, as far as album ID goes, so the track is linked to an album, and then again the albums themselves are linked to artists. Okay, and then the other part that comes in the invoice is the customer ID, and so we could see the first invoice was ordered by customer ID number 2, and customer ID number 2 is this person, Lenny Kohler, Leonie Kohler, I don't know, in Germany, Theodor Heusstrasse in Stuttgart, and this is their phone number and whatever. Okay, so so we want to be able to kind of link these tables together and pull out some information here, right? Okay, so here's a question. It says, provide a query showing the invoices of customers who are from Brazil. The resulting table should show the customer's full name, invoice ID, date of the invoice, and billing country. So I'm taking these exercises from, I didn't cite them, a website here, okay? So, so this is what we're gonna do. Basically, look at this from statement, and this will build how the tables are linked, okay? So we're going to take the customer table, okay? And just so I can kind of save myself some typing, I'm going to rename the customer table as C. And then the invoice table, I'm going to just rename as I. And we're going to link the customer, the invoice and the customer table using customer ID, right? That makes sense. So if I look at the customer table, we have a customer ID, and then we're looking at the invoice table, and it's got a customer ID, all right? And so from there, this is basically the table that I'm building. We're going to join customer to invoice. So now I've got it, you can imagine in your head, you have the customer table and the invoice table, and we've joined them together to form like this big table, okay? And then what we're going to do is we're going to select first name, which is found in the customer table, c.firstname, c.lastname, invoice ID, invoice whatever, okay? So as you read a SQL query, it might be helpful to read the from portion first, okay? And then from there, you can see what columns it's selecting, okay? We're selecting first name, last name, the invoice ID, the date of the invoice, and the billing country, okay? And from here, we want we only want the customers where the customer country is Brazil, okay? That doesn't even have to be selected, okay? I haven't selected c.country equal to Brazil. I just have, I don't have that in the select, so that's not actually going to show up in the results. But I am saying, you know, after you join these tables together, I only want it where this statement is true, where the country in the customer table is equal to Brazil. Okay, and we're going to ask for 20 rows back. And this is what I get, okay? And so we can see Luis, I'm not quite sure how to pronounce this, Goncalves, it's in Brazil, has made 1, 2, 3, 4, 5, 6, 7 different orders, okay? They have 7 different orders ranging from March of 2010 to August of 2013, okay? Eduardo Martins from 2009 to 2013, and then Alexandre Roca, I don't know, from 2009 to 2012, and they are all, their country is Brazil, and their billing country is also Brazil. Now, it is possible that their billing country could have been different. In each invoice, like, because they might have moved and used a different credit card, it is possible for this to have been something other than Brazil, because our condition wasn't that the billing country had to be Brazil. You know, in our data, the results are that the billing country is all Brazil, but that's not required to be the case. Okay? what are the unique billing countries that we have, okay? So we have a keyword in SQL called distinct, okay? So this is kind of like unique, and you can say select billing country, but you're going to say distinct billing country, and so it won't return duplicates, okay? So this will give us all the countries, and we got, looks like we have 24 countries: Germany, Norway, Belgium, Canada, US, France, Ireland, UK, Australia, so on and so forth, okay? So these are the unique values that we have there. Okay. Here's a prompt. It says, provide a query that shows the invoices associated from each sales agent. The resulting table should include the sales agent's full name. Each invoice has a customer, and each customer has a sales rep, okay? So, we didn't actually show it, I didn't actually show the employee table, but that's one of those things, okay? But you can see that as far as the sales rep goes, it's part of the customer table. So the customer table has support rep ID, okay? So the way we're going to get to that information is we have to link customer and the invoice table, and then we're going to link the employee table to the customer table. Okay, so we can join three tables together. We're going to join the invoice table to the customer table and the customer table to the employee table, okay, by using support rep ID. Okay, so let's look at this from section first. Okay, we're going to say from invoice joined with customer. Okay, we're going to do invoice joined with customer, okay, and we use the customer ID and we set that equal to each other. That produces a table. You can then further join that table to another one, right? So invoice joined with customer produces some table that we haven't really named yet, okay? Doesn't even need a name. And then, and we join that with employee, okay? And we're gonna join it where employee, the employee ID is equal to the support rep ID, okay? Because if we look at the invoice table, the customer table, there's a support rep ID. Each customer has a support rep, and we're going to look at that, okay? And so we say join it where the customer table's customer ID is equal to the invoice table customer ID, and join it where the employee ID, employee table employee ID is equal to the customer table's support rep ID, okay? So it's these two numbers that are being linked, okay? So the names of the columns don't have to be the same, okay? So you can have, here this column is called employee ID and this column is called support rep ID, okay? But you do need to indicate how you're going to link them, right? Okay, and what we're going to do is we're going to select the first name and last name from the employee table, and it's going to be, and then we're going to select all the columns from the invoice table. So we're going to just do I.star, okay? You could do E.star, and it's going to do all the columns from the employee table, and I.star, and it will do all the columns from the thing, but you can do that, right? And so it's this aliasing of the tables is helpful to kind of save you some code, right? And then we're going to order by the employee ID. So I'll go ahead and run that. Okay, and so we can see all of these things, all right, have been are Jane Peacock's customers and their invoices. So Jane Peacock is responsible for invoice ID 679, and these are all different kind of customers here, okay? And Steve Johnson's responsible for these ones. And we have a total of 411 basically different invoices available here. All right, so we have basically all the information from the invoice table, but then we managed to extract out the employee table, and I could probably rename these, okay, as employee first, as employee last. Okay, and now that kind of helps keep track of all of this stuff, right? Is that all right? So joining multiple tables is doable, and you just have to kind of set up how these things are going to be linked to each other. Okay, so here even more, so it says we're going to look at the invoice total, customer name, country, and sales agent. Okay, so we're going to look at the first name, employee last name, and then the country and the total of the invoice. Okay, and so you can see, basically the tables that we joined together is the same as before. Employee as E, joined with customer as C, further joined with invoice as I. Okay, and we indicate how these should be linked together. Okay, and we're going to pull out employee first, employee last, customer first, customer last, country, and invoice total. Okay, so I get this. Okay, so I've renamed the columns. Notice what would happen if I didn't rename these columns. Okay. Okay. Here, now I got to. Okay. So here, if I don't rename them, it just pulls. It leaves the column, the titles as is: first name, last name, last name, and that can be confusing, right? So it would be recommended. It's strongly recommended that you you rename the columns. Okay. And general, it's preferable not to use spaces. I should do that. Okay. So we can see Steve Johnson sold Lenny Cooler from Germany, $1.98. Okay. Margaret Park is assigned to both Bjorn Hansen and Dan Peters. Okay. And that's what we have there. Okay. All right, so these are all the different invoices we have. Okay, we can ask how many invoices were there in 2011 and what were the total sales for that year. Okay, so here we're going to just kind of look at the invoice table. Okay, and we're going to kind of select a date range. Okay, so in order to get date information, you have to kind of use this date time function that will turn strings into what it recognizes as dates, so it can compare the dates. Okay, and so so we're going to just say where the invoice date is between January 1st and December 31st of 2013 or 2011. Okay, all right, and there we go. All right. So we have 83 rows there, okay, and then we can ask for the sum, okay. So to do this, what we're going to do is we're going to count invoice ID as count. It's going to take this entire table and aggregate them, okay, and so the result is just going to have one row and two columns, okay. So we're going to take invoice ID and count them, and we're going to call that the count. And we're going to take this column total and sum it, and we're going to call that the sum. Okay. The rest, as far as selecting from invoice I and designating the dates, we can do that. So we can see, indeed, there are 83 rows, and if I took the sum of this entire column, I would get 469.58. Okay, select how many orders were made on each day. We're going to do select the date and the count, and we are going to group by the date. Okay, and we can see orders happened on 71 unique days. Some days had two orders and things like that. Okay. If we wanted to group it by month, we would have to extract the month information from SQL. So let me see. SQL extract month from a date. So how do we do this? Extract month from date. Select month. Let me see if I can do this. I'm not sure. I haven't tried this. Okay, so we're going to do select Let me see if I can do this. It doesn't like this. There's no such function as month. Let me see. SQLite. So there's different SQLite extract month from date. How do we do this? String from time. Okay, so you can do this. %m. Let me see if I can do this as well here. Okay, so you can do it. You just have to kind of look for the different dialects of SQL. You can extract. Let me just kind of write this. Extract the month portion of a date in SQLite by using the string from time function. Okay, so there we go. Okay, so we can see actually, I'm sure this was just generated by a computer, so we had 7 orders every single month, except in November we had 6 orders for a total of 83 orders. So it can be done. You know, we're going to select this as month and group it by the month variable. So there we go. Okay, we're going to look at the invoice line table, and we're going to provide a query that counts the number of line items for each invoice. Okay, so here we have this. So what I'm going to do is I'm going to look at each unique invoice, and we're going to say, okay, this one had 2 tracks, this one had 1, 2, 3, 4 tracks, and I don't know how many this one had, maybe 4 or at least 4, right? And so from there, we're going to group by invoice ID, and we're going to just count the line IDs, okay? And we're going to return that as count. We're going to do it in descending order and just kind of get the biggest order. So invoice ID 5 ordered 14 tracks, and then there were a whole bunch of tracks that only ordered 1. Okay, and so and we have a total of 412 unique invoice IDs. Okay. All right. Here it says find the invoice with the maximum number of invoice IDs. Okay. Oh, and then here it says most elegant. Well, I don't know if this is most elegant. Okay, but I'll get rid of that line thing. Okay, so what we're going to use is something called a common table expression. Okay, so it's like we are going to take this result. Okay, so it's like I take this result and then I'm going to run a SQL query on this result. Okay, but rather than taking this thing where I've counted each counted how many line items there are in each invoice, okay, and storing this, I'm going to just use it as an intermediate step within the query itself, okay? So pretty much I'm just copying this exact text, okay, copy and pasting, select invoice ID, count invoice line ID as count from this, group by this, order by this, okay? And I throw that into this expression, okay, with parentheses here, okay? So here, this is an intermediate table, okay, exact same table that we had in the previous step. I put this in parentheses, okay, and I give this a name, okay, and the way we name it feels a little bit weird, okay. Here I'm calling it invoice counts, and the columns are ID and count, okay, and the command is with this table called invoice counts, which consists of the columns ID and count, and where it's the and you use the word as, okay, which is actually the SQL commands that generate this thing, okay. So I proceed at this, and I say with invoice counts as built up using this as this. From there, we're going to select the max of the count column as max, and the minimum as the min column as min, okay, from invoice counts. So this will return just one row, okay? The biggest order is 14, and the smallest order is 1, okay? So, so we could have figured that out ourselves by looking at this table, but what we call a common table expression allows you to kind of create a table, an intermediate table, right? So it's like you want several layers of summarization, right? So you want to like build one table that kind of summarizes something or selects something, and then on top of that, you're going to run further queries with it, okay? So here, so notice that there's kind of two tiers of summarization, right? So first we wanted to group the invoice IDs together so we can see how many orders or how many items show up in each invoice. And then after I aggregate them that way, then I want to know, okay, what's the biggest and what's the smallest, okay? So you can do something like this if you wanted to kind of aggregate I don't know, total sales numbers for each employee for each month, and then further summarize that and say like, you know, within the month, you know, who was the top or something like that. Okay, so multiple levels of summary. Okay, so here I'm using the same thing where I've aggregated them into this table. Okay, and again, I don't have to save a separate table. Okay, and then from there we're going to kind of summarize this by count. So I can say how many orders have 14 items, how many orders have 1 item, how many orders have 2 items, and things like that. Okay, so there are 59 orders where they only ordered 1 track, 117 orders where they ordered 2 tracks, and then 59 orders where they ordered 4, 6, 9, and 14. Okay, and so now the fact that this is like simulated and generated starts to become more apparent because these numbers are a little bit too artificial, right? We're getting exactly 59 orders where they ordered exactly 9 tracks and things like that. Okay, but it's fine, it works. Okay, this can get even messier, okay? But we can do stuff, right? So here, we are going to include the track name and artist along with each invoice item. So we're gonna look at the invoice line item thing, okay? And if we look at the original invoice line item table, it's missing quite a bit of information, okay? So as far as the line item, all it does is it says line ID and track ID, okay? And so we say, well, okay, well, we can go to track ID, but the track ID just has, doesn't have anything about the album name. I mean, it just has the name of the track, but it doesn't have anything about the album or the artist. There's a composer, okay, which I guess can be different from it's maybe like the producer, which can be different from the artist, but we only have the name of the track, okay? And if we want the artist name, we actually have to go through album ID because there's no artist associated with each track, okay? So, so notice how we have to do this, okay? We're gonna go, to build this, we have to join we have to perform 3 joins, okay? So we're gonna take the invoice line ID table, okay, and join it with the track table, all right? And we join using the track ID, okay? And then we're going to join that with the album ID table, okay? Or the album table. So we're going to look at each track. Each track has an album ID, and we're going to link it up to the album table. And then we're going to join the album table with the artist table. And that way we can pull out the artist ID, okay? And then so here we're going to say select everything from the invoice table and also the track name as track. The track name as the track and the artist name, okay? And then everything else from the invoice table. So I'll go ahead and run that, and then and so we have a total of 2,240 rows, but we can see we get the track name and the artist, and each of the things that show up in the invoice table. So it all appears there. But again, it requires us to kind of link through join a whole bunch of tables together. Okay. Here's just kind of this nice little visual that shows the different kind of joins. All of the joins I think that we have done are inner joins, okay? Just if you do join, it's automatically going to default to an inner join, but you have different kinds of joins. So this is just the regular old join. This is the intersection. The outer join is the union, okay? So here's the kind of the examples. You have table 1, which has pirate, monkey, ninja, spaghetti, and table 2 has rutabaga, pirate, Darth Vader, and ninja, okay? And so if we do the inner join, we're going to just get the pirate and ninja because those are the ones in common. If you do the full outer join, you're going to get all 6 values, okay? But the ones where it's in the left table but not the right table, you get nulls for the right table. And the ones that are in the right table, like rutabaga and Darth Vader, you get nulls in the left table. Okay, the left join does everything in the left table, okay? And we get nulls for every things that don't match in the right table. And then the left outer join is this, and it gives you everything that's in the left table that has no match in the other table, okay? And then the full outer join is basically the disjoint set here, okay? And okay, and then there's I guess the cross join, which we won't discuss here. Okay, so but this is a handy little reference as far as SQL joins goes. This is from way back in 2007, but it's still useful, I believe. All right, I guess we're going to end a little bit early today, but I don't know. I don't know if you have further questions regarding SQL or any kind of SQL practice or things like that. There's quite a bit of stuff. I don't want to get into like optimizing your SQL queries for speed and things like that. That's like a little bit more advanced. You can look up books like Pro SQL that talk about stuff like this. But as far as just getting started, I think on Monday I linked to some resources for practice, and I think those are going to be kind of your best bet if if you need to interview for some job and they say we want you to have SQL, spend a couple days working on that. Okay, I think it's simple enough where, because you have all of this experience already summarizing data using dplyr and now pandas, that doing stuff in SQL is just using that same brain and just changing the words that you're using, select and where and things like that. But conceptually, how you aggregate data, those skills you already have in your skill set. All right, we'll end here. Have a happy Thanksgiving. Hope you guys enjoy your weekend, and we'll see you guys 10th week for your final presentations. I look forward to them. Okay, and it looks like nobody signed up for Monday. Okay, so I'll be here on Monday. Okay, I'll be here on campus on Monday. And if you have questions as far as like just you want to make sure your group's on the right track for your presentations and stuff, feel free to stop by my office, okay? I guess I'll just have kind of extended office hours on Monday. Stop on by. I'm happy to kind of give you some help there, okay? Because nobody wanted to present their final presentation on Monday. I get it, okay? So with that, have a happy Thanksgiving, and we'll see you for your final presentations.